Find the coordinates of the points of inflection on the curve given here. Now, whenever you're asked to do this, you're going to look for points where d2y dx squared equals 0. So, dy dx is going to be 15x to the 4 minus 80x cubed plus 30x squared plus 360x plus 180. d2y dx squared is then going to be 60x cubed, take away 240x squared plus 60x plus 360. So we want 60x cubed minus 240x squared plus 60x plus 360 to be equal to 0. Now there is a common factor of 60 in these terms, so we can divide through by 60, giving us x cubed minus 4x squared plus x plus 6 is equal to 0. And so we have to solve a cubic equation. So this is a reminder of how to do that. So f of x is x cubed minus 4x squared plus x plus 6. Now what we need to look for is a value of x that makes this function equal to 0. This is using the factor theorem. I do have lessons on the factor theorem. I know I have them currently in year 10. So, what value of x would do that? F of negative 1 is going to be negative 1, take 4, take 1 plus 6, and that is indeed equal to 0. And by the factor theorem, that tells me that x plus 1 is a factor. Now you can proceed by algebraic division, but what's even quicker than that is just to say, okay, x plus 1 times some quadratic will give me this cubic. So I've got an x cubed term here. That tells me that this needs to start with x squared, because then when we expand out we get x cubed. I have a plus 6 here. There's a plus 1 in my bracket. So if I put plus 6 here, when I expand out, I'll get a constant term of plus 6. Not quite sure what goes in the middle, but we can get that by comparing. If I decide to compare the x squared terms, negative 4x squared is going to be equal to, what's going to give us x squared from here? Well, that will, and that gives me just 1x squared. And then this will, which will give me ax squared. Get rid of the a squareds, and I've got negative 4 equals 1 plus a, telling me that a is negative 5. So I now have x plus 1, x squared, take 5x plus 6 is equal to 0. So x plus 1, x minus 2, x minus 3 is equal to 0, giving me that x is equal to negative 1, 2, or 3. Now the question did say coordinates, so I need to take those values and substitute them into this function. Now I just paused and plotted the graph, and then I can find those y values using a y-cal. So when x is -1, I get -133. So we've got -1, -133. And when x is 2, so I want another y-cal when x is 2, and I get 836. I feel that might have gone off the top of the graph, so I'm just going to change my view window. Let's put this up to, say, 2000. And then if I go for a G-solve y-cal when x is 3, and that gives me 1439. So that would be 31439. Okay, so if I do a G-solve now and look for inflections, we can see that the -1, -133 is a point of inflection just here. There's one here and one here. And this section of graph really doesn't look like it's doing much. But if you go and zoom in, you'll find that there is a bit of snaking going on, and that's how we're getting points where the gradient is either maximized or minimized along a section.